Alright, this is the last set of PowerPoint notes for our Unit 3 notes on chemical and physical properties. So this is PowerPoint number 7. You need to find in your notes on page 7, capital letter C, I think is where we are, where it has physical versus chemical changes. So we talked about physical versus chemical properties. Now we have to talk about physical versus chemical changes. Physical changes, this is when you change the form of the substance without changing its identity. Again, you change the shape of the paper by tearing it, but it's still paper. Even if it's in little bitty pieces, it's still paper. Now, examples of these, the great examples of these would be the phase or state changes. You might be more familiar with them calling them changes of state. You might be more familiar with them calling them phase changes. So when it changes state or when it changes phase, it's the same thing. So we have melting to freezing. So when you have a solid that changes to a liquid and vice versa, you're talking about melting and freezing. That's just a physical thing. When you have, and let me backtrack and give you an example. Always think of water. If you have liquid water and you freeze it, it's still H2O, it's just in a solid form. If you had liquid water and you heat it up so it converts to steam, it's still H2O, it's just in a gas form. And you know this when you take a shower in the morning and the mirror's cold and it steams up, it fogs up the mirror. That's just steam water that had changed to a gas, and then it condenses back down to a liquid onto the mirror that you have. Boiling and condensating or condensing, that's when you change the liquid to a gas and vice versa. Sublimation is a weird one, and you'll have to study this one. Sublimation and deposition. Sublimation is when you skip over the liquid phase. You take a solid and go straight to a gas, or you take a gas and go straight back down to a solid. You guys have played with dry ice before? Dry ice, if you get some of that, it has a solid form, and it changes directly to a gas. There's no liquid form. You can take a chunk of dry ice and put it on your desk and let it melt. It doesn't melt. There's no wet residue afterwards. It goes straight to a gas. That's sublimation. When that gas goes straight back down to a solid, we call that deposition. So solid to a gas and gas to a solid. Another example of a physical change would be things dissolving in water. So you notice that the physical changes and physical properties in many cases go hand in hand. If we take something up in a mortar and pestle and we grind it or tear it or crush it, those are all examples of physical changes. Oh, look at the pretty drawings. We have a solid in the first, and notice that it does not take the shape of its container. We have a liquid in the second. It does take the shape of a container, and see still how close the molecules are or the atoms are. And then in the third one, we had to put a lid on it, and we have the same number of atoms, I believe, they kept in there, but they're all spread out to fill up the container. So we have a gas. So when we melt, we go from a solid to a liquid. When we evaporate, we go from a liquid to a gas. And then we can go back from that. If we go back the other direction, if we condense, we go from the gas state down to the liquid state. We lose energy. The molecules aren't moving around so crazy again. They're moving slower. They're still in constant contact, but they're not moving as fast as they were in a gas. And then when we go from the liquid to the solid, we lose even more energy. We call it freezing. Okay, number 2, chemical changes. Chemical changes are changes that alter the identity of a substance. Whatever you started out with, that's not what you have in the end. The products, the things that are produced, have new and different properties now. So there are multiple signs that you can look for to see if a chemical change has occurred. And usually you do look for multiple signs because sometimes the things can be misleading. For example, if you have a change in color. If I put food coloring in water, is that a chemical change or a physical change? It's physical. It's still water, right? You can still drink it. So you have to be careful and look for an unexpected change in color or an unexpected change in odor. So if you put a pink substance and a blue substance together and all of a sudden it turns purple, all of a sudden it turns green, that's an unexpected color change. An odor, a strange odor, is also an example or a little flag that says, hey, there's a chemical change going on here. Also, you look for bubbles. These are signs that a chemical change has occurred. You're producing some type of gas. You're looking for bubbles. If it forms some kind of precipitate, so you put 2 clear liquids together and it all of a sudden turns cloudy, and if you let it sit, there's this solid gunk that settles down to the bottom. So a precipitate is a solid product which forms in a chemical reaction. All those are little signs that say, hey, a chemical reaction has occurred. Signs of a chemical change, again, this is just further on. We have a change in light or heat. If it puts out heat or it turns really cold, that's usually a sign that a chemical change is occurring. If it puts out light, like it flashes all of a sudden, or like a firecracker, it's going to put out light and heat. You have an example or a sign that a chemical change has occurred. If it changes texture, think of, this is kind of gross, but think of milk. And now think of the milk when it's spoiled. If you let that milk sit there a while, doesn't it get kind of chunky? So it changes from a nice runny fluid to a chunky mass of nastiness, and you can also tell there's an odor there to it. And definitely you've got a taste change, right? And then also it says you can have a mass change. And this is only going to occur if you have an open system. Like if you're letting a chemical reaction go on in a beaker and a gas is produced and you don't catch the gas, then it looks like there's been a mass change of some kind. Or let's say you leave a nail outside and it's all rusty, and before you use it again, you wipe it off. Well, you've just taken off some of the mass, and so it would seem like there's been the nail now has less mass than it had. So when it says mass change, it doesn't mean that the law of conservation of mass doesn't apply. It just means that it seems to be a change in mass of what's going on. Okay, here are some examples of chemical changes. Corrosion, and these are terms that you'll find on the tax test or on the end of course exam. Corrosion is when you have a slow reaction and it's wearing away of metals, like rusting, tarnishing. Those are examples of corrosion. Something slowly gets eaten away. Rusting is when you have iron that reacts with oxygen. So you started out with pure iron and you ended up with a compound, iron oxide. If something's set on fire, you have something burning, that's an example of a chemical change. Tarnishing is another one, and tarnishing is usually associated with silver. It's kind of like we use a word called verdigris for when copper turns from that coppery color to the green, it gets that gunk on it. And that's really just the copper combining with oxygen. The same way here, when silver tarnishes, the silver is combining with the oxygen. It's kind of like rusting only on silver, so we have to give it a spiffy name. And then, of course, we talked about this in class 2, digesting. When you digest food, you have both a chemical and physical reaction. If you just bite into the food, that's just a physical thing. You're just changing the shape of the food. But once you start pouring chemicals on that food, like the saliva with the amylase that we talked about, or the hydrochloric acid, or all the different chemicals that are produced by the body, once you start dumping chemicals on it, you slowly have a chemical change occurring. And again, you know this by a gross manner, because if you've ever thrown up, you know that it might have tasted good going in, but it doesn't taste quite the same coming out. So you definitely have evidence of a chemical reaction. Now, as it says on the slide here, what goes in one end does not look or smell like what goes out the other end. So you have truly treated the food that you ate with a lot of chemicals, and you have something other than nice and spiffy food coming out the other end. So we have types of changes again. So you've got a list here. Are these physical changes or chemical changes? So number 1, melting chocolate. Okay, so it's melting. You know it's going to be a physical change. Lighting a match. If you set something on fire, absolutely going to be a chemical change. Erosion of a riverbed. All right, so you're taking water and you're making the water run down, and it's going to pull the dirt away. That's just a physical change. You're just moving the dirt from one place to the other. You haven't changed what the dirt is. So you have a physical change. You have a red mark that appears after a bee sting. Well, what did the bee put in you? Did he inject a chemical? Yeah, he did. And that's why we have a red mark. We have this little reaction to getting a chemical in there. Our body does all sorts of cool stuff. It opens up the blood vessels in the area, so it brings in blood to the area to try and deal with the problem. And then what about cooking waffles? You have the waffle batter, and you cook it. Now, remember, sometimes when you heat things, it's just going to cause a physical change, but sometimes if you heat it long enough at a higher enough temperature, then you can trigger a chemical reaction to occur. So the waffle batter doesn't look, it doesn't taste, it doesn't seem like the waffles themselves, so we have a chemical change going on.